Okay, we're asked to look up the formulas for the volume of a cone in the back of the textbook. So I've written the volume of a cone and the volume of a cylinder. For the cone, it's 1/3 pi times the radius squared times the height. For the cylinder, it's pi times the radius squared times the height. We're going to name R the radius of both the cone and the cylinder, same measurement. The height of the cone is h sub 1. The height of the cylinder is h sub 2. V sub 1 will be the volume of the cone, and V sub 2 will be the volume of the cylinder. We're given that h sub 2, the height of the cylinder, is 4 times the radius r, and h sub 1, the height of the cone, is equal to 2 inches. And we were told that the volume of the entire rocket-shaped firework is going to be 114 times pi inches cubed. So that means the volume of the cones, V sub 1, plus the volume of the cylinder, V sub 2, will equal a total of 114 times pi. That's where we're going to begin. V sub 1 plus V sub 2 equals 114 times pi. Now replace V sub 1 and V sub 2 with the formulas that we got from the top line here, and replace be sure to use the right H values. H sub 1 for the cone, H sub 2 for the cylinder. Now we're going to clean this up. We're going to actually just replace the H sub 1 with 2 and H sub 2 with 4 times R, because that was in the given information. Now we're going to divide all the terms on both sides by pi, because that's a common value, and that leaves 1/3 times 2 R squared plus pi R squared, I'm sorry, no pi, 4R squared times R, which is R cubed, and then 114 on the right. Next, we'll get rid of the fractions by multiplying both sides by the LCD, which is 3. And you'll see what it does is it's going to cancel out with the denominator, but it's also going to increase. We're going to multiply all the other terms by 3 also. So some numbers will get bigger. This is 2R squared plus 12R cubed equals 342. And finally, we have a common factor of 2 everywhere, so we'll divide both sides by 2 to simplify it. R squared plus R to the third equals 171. Turn that around, 6R cubed plus R squared minus 171 equals 0. Think of these as x values, not r's. So you have 6x cubed plus R squared minus 171 equals 0. We have to find the roots to find the radius, because x is r now, it's a radius. So let's try some of our methods. Let's find the integral upper bound on roots. We'll do synthetic division by positive whole numbers, 1, 2, 3. We'll keep going until we get an upper bound, all non-negative numbers on the bottom. Be sure to put a 0 in for the missing power of x to the first. So we bring down the first number, we distribute multiplication, we add. No, negative 164 for remainder, that tells us nothing. So let's continue. We're looking for all non-negative on the bottom. We got 6, we got 13, we got 26, and we have negative 119. No, that doesn't tell us anything. And now let's try 3. Synthetically divide by 3. And we have 6, we have 19. We have 57, and now from that negative 171, we add 171. Yeah, we got a 0. We were looking for an upper bound, but we actually found a root. The number we were dividing by, 3, is a root. And we can use that to start factoring. The original polynomial being equal to 0 can factor as x minus the root times the numbers that are remaining on the bottom of synthetic division, 1 degree lower than the original polynomial. Then we need to figure out what the roots are for that large factor. We can just use the quadratic formula now, because this is second degree. So we're going to figure out what a, b, and c is in this 6x squared plus 19x plus 57 and plug it into this formula. Negative b plus or minus the square root of b squared minus 4ac. So plug your a, your b, your c into the equation. Now remember, we're looking for a radius measure, which means it has to be a positive number, a positive real number for radius, because it's a length. So we have negative 19 plus or minus the square root of negative 107 over 12. Uh-oh. Square root of a negative number? That means this is not a real value. There is no other root that's real but x equals 3. Thus, the only solution we found was x, which is a radius, r, is equal to 3 inches, and we are finished.